Good, thank you. So thanks for giving me the opportunity to give a presentation this afternoon. I'm a little sorry that we could not meet in person this year, but I hope we can meet again soon. So we have heard a bit about ultrafine particles this afternoon, and I will go further in this topic. So I will address a few questions. The first one is, why is there a need to measure ultrafine particles? So ultrafine particles are defined as particles with 100 nanometer or less in diameter. So as you can imagine, it's more than 25 times smaller than one particle of 2.5 micron in diameter. Is there a need to harmonize the measurements? What are the current technical specifications from the European network to be implemented over Europe? And how TSI solution can support this harmonization? So, it is a known fact that air pollution has a direct effect on people's health and lead to premature death every year. We've heard about that a few times during the conference. Particulate matter has been identified as one of the harmful pollutants. And for more than 20 years now, the European directive started to set limit values for particulate matter in ambient air. PM2.5 and PM10 are since then monitored, and action has been taken to reduce them. These guidelines from WHO are regularly revised, as it was presented yesterday morning. There have been many studies on this particulate pollution, and while it remains true that PM10 and PM2.5 are harmful for the health and should be limited, it is now proven that these two values are not describing the particulate pollution as a whole, but ultrafine particles are playing an important role. Indeed, the size of the particle is important, as presented this morning as well. There are lots of publications on ultrafine particles in the last 30 years, but I highlight here a white paper which was coordinated by Fleming Cassie, Lydia Morawska, and Annette Peters, and which gives a very good understanding on the current state of knowledge on the effect of UFP. I believe this white paper should be read entirely, but here are a few sentences that are applicable to my talk this afternoon. So in general, the total and ultrafine particle number concentration were poorly correlated with PM2.5 levels. Association has been observed between UFP exposure and health effects independently of other metrics of air pollution, such as PM2.5 and others. And finally, it says that particle number, size distribution are most commonly measured with relatively well-established methods. However, there is no standard method selected, which makes it difficult to compare results from different exposure epidemiological studies. And I will address particularly this last sentence. So as I said, for more than 30 years, there's monitoring station, and there's more and more station monitoring particle number concentration and particle size distribution, which enable to gain experience. But over the years, the measurements were made differently with different instruments, different sampling line and conditioning, different quality protocols and reporting. So this led to difficulty to compare the measurements. Today, things are moving into the harmonization of aerosol in situ particle number and particle size distribution measurement. The European Committee, CEN, has set two technical specifications, one for the measurement of particle number concentration and one for the measurement of particle size distribution, and all that in collaboration with different networks. So it has been mentioned ACTRIS today. We have as well the Global Atmospheric Watch Network, which have been given different recommendations. So these technical specification describe the instrument specification, but as well as the setup and sampling specification, the measurement procedure, and importantly as well, the data processing and reporting, and the quality control and assurance. As a company in this field, the goal of TSI is to support the community with state-of-the-art instruments, ranging from individual components to global solution. So in fact, a few years ago, I already had the opportunity to give a presentation during the conference, and I presented the CEN TS16976, which is for the measurement of total particle number concentration. And this technical specification describes the requirements for the instrument, the sampling line, and the data record format. And I presented as well our solution, which is compliant to this technical specification. So it's a CEN CPC and a sampling line. So more recently, there's a new technical specification, as I said, that has been added for the particle size distribution from 10 nanometer to 800 nanometer. So it is done with a scanning mobility particle sizer, MPSS, and this measurement should be done in parallel of the measurement of total particle number concentration with the CEN CPC. To have a complete solution, you need a CEN compliant sampling system as well, so a sampling line with adequate conditioning. You need a relative humidity and temperature sensor, as this needs to be reported together with the data. And for the complete system, you need some accessories like vacuum pump and butanol removal, catalytic vapor filter, and a software which can export the data in the required format. I have limited time for this presentation, but I invite you to check this document, which is freely accessible on our website, and which goes into more details on the technical specification and on TSI instrumentation. I move now to some results, so some data that has been taken with this new instrument by my colleague in Germany. So TSI office is located just in front of a bus depot and very close to highways. My colleague did 24 days continuous measurement with one SMPS, 2 CPC, and all the 3 instruments were connected to a compliant sampling system. The graph you see here is showing the size distribution versus time, and the color is the concentration. So as you can see, there's lots of emission of particles between 10 and 100 nanometer. This plot shows the total particle number concentration as measured by the 2 different CPC. So the difference, they are the same CPC, but the lowest cutoff, the D50, is different. One is 7 nanometer and the other one is 10 nanometer, whereas the SMPS measures from 10 nanometer to 800 nanometer. So they compared the total concentration with the 3 instruments over time, and you can see lower emission in the weekend due to the lower traffic. So why did they use 2 CPC with 2 different D50? In fact, the technical specification for particle number concentration was set initially to 7 nanometer, But now that the new technical specification for the size distribution set a range from 10 to 800 nanometer, the D50 for the cell CPC may change as well. And this is explained here with these two curves, so where they compare the total number concentration of CPC at 7 nanometer and 10 nanometer versus SMPS. As you can see, the correlation on the left with the 7 nanometer is pretty good, but on the right, the slope is closer to 1 and the data are more symmetrical, which shows a better agreement. Finally, one question which is important to take into consideration when running instruments in a network is the data handling. So what are the parameters that should be reported? What are the data that you need to handle locally to make sure that everything is working well? And what are the data that needs to be sent to the central database in order to be harmonized in the same way as other people in the network? And what protocol do you need to use? So all these questions are specific to users and or to networks and should be discussed very early with us in order to make sure that we can meet your requirements. So as a conclusion, I presented a complete new solution for both particle number and particle size distribution measurements according to technical recommendation, and including not only the instrument, but the conditioning, all the accessories, and the data transfer to central station. And as an outlook, I wanted to highlight that a good number of ACTRIS stations and even some national and regional environmental protection agency has now started to order these new solutions, and harmonized dataset over Europe should be accessible in the near future. Thank you.
Thank you very much, Severine. It's very interesting. I hope we will have an opportunity to test your instruments very soon. Some of us. Who wants to ask Severine something or to comment something? Okay.